All right, we have another lovely puzzle. Let's see. So we have a triangle, not necessarily right, but it contains 3 squares with their area is given, and we have to find the area of the big triangle. Something like this. So left to right, the areas are 4, 36, and 9. But I don't want to write that. I think it might mess up the picture. Let's just translate that immediately to sides. So this square has sides 2 and 2. And this square has sides, doesn't look like a square, does it? This square has sides 6, and this square has sides 3. So we know a great deal from the base, but we don't really know the base. I'm thinking the area is base times height. And so we're missing stuff from the base, and we don't know much about the height at all. But I see lots of right angles and lots of parallel lines. Because we want to find the height, I think it's a good idea to draw that in. Tables are always at the wrong spot. Okay, there we go. And what I see is right angles. And this angle is the same as this angle, So I see here 4 right triangles similar to each other. 1, this one here, 2, 3, and if all else fails, this is the 4th one, right? And this is not 90 degrees, so we don't know much about the other side, but the same stuff is going on the other side. They're sort of along parallel lines. And now we're looking for we need to know something more. And the key is this triangle. And the same triangle, this triangle here. That's going to be the key, because if the whole vertical side of this big square is 6 and this here is 2, that leaves this to be 4. So we know a great deal about this particular triangle. This is not the semi-regular triangle. This is the one that I call the domino triangle, where one side is half of the other side, but not the hypotenuse. It's when you have 2 squares and you put them together. I think that's what's going on here, because 2 and 4, but neither of them is the hypotenuse. We can think of this angle whose tangent is 2, right? Tangent alpha is 2 over 1. But either way, these 3 or 4 right triangles are similar to each other, which means that, if this is 2 and this side corresponding to this side, then it should be half. This is 1. And this one, we don't know much, and we don't know this either. And there is another bunch, so I'm thinking maybe we're going to need 2 variables. So let's call this A. And no, we don't need to call it B, because if this triangle is similar to the rest of them, this can be called 2A. And then, so rinse and repeat on the other side, right? So this vertical side is 6, the whole thing. This is 3. So what's remaining is 3. So these triangles here are the isosceles right triangles, where the 2 shorter sides, the legs, are equal to each other. Well, that helps. That will make this here 3 long. So we actually know the base. The base is going to be 1 plus 2 plus 6 plus 3 plus 3. So 12 plus 3, that's 15. So we already know the base, it's 15 units long. We just have to figure out the height. Well, if this is the isosceles right triangle, then this is also 2a. And this together, which is 3a, is 6. So here is our equation. A plus 2a equals 6. Wasn't that bad. So 3a is 6, a is 2. And then we know the height too, because if a is 2, then 2a is 4, and this remaining thing is 6. And so the height is 10. 4 plus 6. And so the area is base times height over 2. So that's half of 150, that's 75. Lovely party. Thank you for watching.